Hi everyone. Happy Friday. I hope you're having a great day. Today we're going to be talking about adding and subtracting rational expressions. Please take out some paper and something to write with, either a pen or a pencil, because we're going to be taking notes for a bit. So you can see up here on the board that I have two fractions. I have 1/6 plus 5/6. Remember, rational expressions are a lot like fractions, so we're starting with the fractions and working our way up to the more complicated rational expressions. What I want you to think about now is, what do these two fractions have in common? Hopefully you noticed that these fractions have a denominator in common. 6 is their common denominator. If you remember from previous classes, when fractions have a common denominator, we leave the denominator alone. It stays the same. And then we simply add the values in the numerator, or subtract if that's what it's called for. So when we do the 1 plus 5, we get 6 over 6. Now, this fraction could be simplified, of course. And we know that 6 over 6 is equal to 1. Okay, so now let's move on to some examples with variables. So these two technically are polynomials because they have their variable in the numerator, not the denominator. But it's still the same idea. We're adding two things with different denominators now. So what do we have to do to add two things with different denominators? We have to find a common denominator. To find a common denominator, we have to find the least common multiple between the two numbers. So we're going to call this the LCM moving forward. It's a little faster to say. What the least common multiple means is that it is the smallest number that you can get by going through the multiples of each of the two denominators that you're comparing. So for example, we can count up by twos and go 2, 4, 6, 8, 10. If we count up by fives, we go 5, 10. You see that we hit 10 in both of those lists. That was the first number they had in common, and it makes it the least common multiple. That means 10 is going to have to be our new denominator. Now we have to figure out what we have to multiply 2 and 5 by to get to 10. So we know that 2 times 5 equals 10, and 5 times 2 equals 10. Whatever we do to the denominator, we also have to do to the numerator of our fraction or our rational function. Therefore, we're going to multiply the numerator of 3x over 2 by 5 and the numerator of 2y over 5 by 2. So from there, we're going to get 3x times 5 is 15x. And 2 times 5 is 10. And that'll be plus 2y times 2, which is 4y, over 5 times 2, which is 10. Now that we have a common denominator, all we have to do is add the numerators together. Since 15x and 4y are not like terms, we can't combine them any further. We can just give them the same denominator of 10, and that's going to be our final answer. For our next problem, we have a similar situation where we have two different denominators. So we're going to have to find a common denominator again. We do this by again finding the least common multiple between 15 and 5. So let's start listing our different multiples of 15 and 5. So we have 15, 30, and let's just pause there. Then we have 5, 10, 15. Looks like 15 is our least common multiple. It's the first number we repeated on both lists. Since 15 is already the denominator of our first rational function, we just have to multiply the top and the bottom of that by 1. It's not really necessary, but I'm just doing it here to show you. 5 times 3 is 15, so we have to multiply the denominator and the numerator of the second rational function by 3. So we're going to have 2y over 15. That first rational function doesn't change. Minus, and now we're going to distribute that 3 into 2x plus 3y. So 3 times 2x is 6x. And 3 times 3y is 9y. And those will both be over 15. Now that we have the common denominator, we can subtract 6x and 9y both from 2y in our numerators. So we'll put our 15 in the denominator. We're going to have a negative 6x because of that minus sign in front of the 6x. Then we're going to do 2y minus 9y, which is going to give us negative 7y. And that is our final answer for this subtracting rational functions problem. For this next problem, we have a common denominator, but notice that that denominator is made up of a binomial instead of a whole number. So luckily, the ease of having a common denominator isn't going to change just because our denominator is a binomial. So we're going to keep x minus 5 as our denominator in our answer. And we're going to have 5 plus 4 as our numerator. 5 plus 4, of course, equals 9. So we get 9 over x minus 5. This was a quick example. Pretty easy, right? In this problem, we have two different denominators, and both of those denominators have a variable in them. We have a binomial and a monomial. In this case, we're going to get the least common multiple by multiplying the two denominators together. So we'll multiply the denominator and the numerator of our first rational function by x, the denominator of the second rational function, and the denominator and the numerator of the second rational function by x plus 2, the denominator of the first rational function. So let's get our new numerators first. X times negative 3 is negative 3x. That will be over our new denominator of x times x plus 2. Then we distribute the 7 through the x plus 2 to get 7x plus 14. Now that we have our new denominator and our new numerators, we can add together all of the items in the numerator. So negative 3x and 7x are like terms, so we can add those together. Negative 3x plus 7x is 4x, and then our 14 gets left alone. This is going to be over our new denominator of x times x plus 2. And that is our answer for this problem. So I bet you're wondering what we do with this problem now. I know, they keep getting more complicated. It's going to be hard to figure out what we multiply x minus 2 by to get that least common multiple. To figure that out, we're going to have to factor our other denominator. We're going to use our snowflake method again. Draw our snowflake. Our a value is 1. Our b value is negative 3. And our a value times our c value is 2. Now, because the top number is positive and the bottom number is negative, that tells us that both of our factors are negative, because two negatives multiplied together make a positive. 1 times 2 equals 2. So negative 1 times negative 2 equals 2 as well. Negative 1 plus negative 2 gives us negative 3, so that works out. So we have x minus 1 times x minus 2. And those are our factors for our denominator in our first rational function. So there we have the x plus 2 that we have in the denominator of our other rational function. So that means that we just have to multiply the second rational function by this new piece, x minus 1. Since we don't have to multiply the first rational function by anything, the x minus 7 is going to stay the same. Our new denominator is x minus 1 times x minus 2. And then we're going to have to distribute the 4 to the x minus 1 in our second rational function. So 4 times x is going to give us 4x, and 4 times negative 1 is going to give us negative 4. Now we're going to combine our like terms in our numerator to get our final answer. So x and 4x are like terms, so we can add them together to get 5x. Negative 7 and negative 4 are like terms, so we can add those together to get negative 11. So we get 5x minus 11 over x minus 1 times x minus 2. If you want, you can FOIL the denominator together again to turn it back into x squared minus 3x plus 2, but this answer is perfectly fine. Moving on to a few more examples, please copy these into your notes. Let's take a look at the first problem together. So our denominators are x and 5x. So we have to multiply the first rational function by 5 in the numerator and the denominator to give us that common denominator. We're going to distribute the 5 to the 2x minus 5. So 5 times 2x is going to give us 10x. And 5 times negative 5 is going to give us negative 25. Then we're going to subtract the 4 from our second rational function, because it's minus 4 over 5x, and put it all over our common denominator of 5x. Now, we're going to combine our like terms again, which are the 25 and the 4. So we'll have 10x minus 29 over 5x. Please take about 5 minutes to try these two other problems on your own, and I'll write the solutions up on the board.
Wow, that's some great math you're doing right there.
Hopefully you feel ready to try some of these on your own now. So the substitute is going to give you a worksheet, and I want you to try the odd numbers on the left side of the page. So odd numbers 1 through 11. Give those a try and see what you can get based on the lesson today. On Monday, we'll go over this information and any questions that you may have. Have a great weekend, guys.